This is Leetcode 100, finding same tree. So we're given, I guess I don't want to read the question, or you probably can read it yourself. The question is, in general, saying uh, basically detect if you were given a two trees and just detect if they're the same or not. I mean, there's depth first search is quite simple, but because this is breadth first series, we will use breadth first search. Honestly, this question, the main value is literally just to teach you. This teaches you a pattern where you're iterating, where you're traversing through the list. Sorry, not the list. You're traversing through the tree, two trees at once using breadth first search, and it's a pretty neat pattern. I've seen some other questions use it as well, so I thought I'd make this video. So yeah, you got these two trees. How do you traverse both tree at the same time using breadth first search, right? Well, you can kind of like it's kind of the same as traversing one tree, but instead of like putting a single node into a queue, you just put a tuple in, and you can kind of go, yeah, you put a tuple into a queue. This is a 2D structure that we've been imagining in this series, right? We've been kind of practicing to imagine turning the single one-dimensional queue into two-dimensional. I think hopefully it's not too new. If you're watching this video, but yeah, we can do this. We can kind of imagine this 2D structure, queue structure, and just kind of treat it, kind of imagine it in mind like a 2D grid, right? And treat it like how you would iterate it in a way that like how you would iterate a 2D grid, like a matrix, right? Double for loop or nested for loop, whatever. And yeah, and you can kind of go like work with, you can kind of pop out each node, right? You can go check out each cell and check if the content of the nodes are same or not, right? um, so yeah, I mean, that's how you do it. um, the Let's have a look. All right, okay, so let's have a look at the solution. Okay, so solution kind of builds off the breadth first search, right? I mean, if you kind of, this is a general pattern, right? You got this nested while loop, while loop with a nesting of for loop to kind of like play around with the 2D structure, right? A grid, and yeah, this should hopefully not be too unfamiliar for you. And the only thing that's new is this particular edge case. Like, so this kind of changes question to question, right, depending on what you want to do and like what the most intuitive thing is to do with that question, right? It's like, okay, so we're at a level and we're processing a particular node, we're at a particular row, which is a level, right? And we're processing a particular cell within this for loop, right? And the operation could just differ. This is question variation, right? Like, and um, in this case, you want to make sure both nodes are, an actual node, right? So an edge case would be like, oh, um, like the P and Q, the arguments are both none, right? So just kind of handling that. But also the leaf nodes, right? Handling like when there could be a scenario where you have none, like so imagining a scenario like where you have a cell value of like I don't know, imagine this was a big list, right, and big 2D grid. You have some kind of, somewhere in the grid you got like none, like null values pair, null value pair, right? um yeah, so if that's the case, if the cell contains a null value pair, then we just want to move on to another cell, right? Like we just want to move on, process another cell, so continue that. um and if none is, so if this is like when one contains actual node and the other one doesn't contain, um and the other one doesn't contain. So I think over here the main point is like you're just kind of thinking about the different permutation or combinations of the pair, right? That could exist. Oh, one. One node could be null, the other node couldn't. Like, what if one node is null and the other isn't? Or what if, like, both are null? Or what if, okay, uh, what if both are not null and contain some value, but they're different, right? And you're kind of thinking through these edge cases, but you just, at a level, you're just considering, a cell operation, right? So it's not that difficult, and the rest tree traversal is kind of taken care of already, um, with this particular format, right? So yeah, I mean, it's nothing too difficult on this one. Uh, yep. So that's that.